Hello, my name is Omar Basri. I'm one of your PIs for this Digital Logic Fall 2024 semester, and I'm going to be doing a short overview of some of the things in Lab 2 that have caused confusion. So the main part of the Lab 2 is this component right here, the D flip-flop. The main thing about this D flip-flop is that you don't need to know the internals for now. It's basically just a bunch of NAND gates connected to each other, but it has two inputs we care about and one output. The reset, basically just whenever it's low, the output will go to 0. But basically, you can think of the D flip-flop as storing a single bit. Whenever this clock edge goes high, so as you can see right here, it goes high here, here, and here. So just whenever it goes from 0 to 1, whatever is in the input will be put in the output. And when it's not a rising edge, everything else, the output will just stay stagnant. So let's say that like on this edge right here, D is equal to 0, so then Q will output 0. If we change D to 1, say right here, that change won't be reflected until this next clock edge. So we can basically use this as a form of storage. We can store 1 bit in it. So each D flip-flop stores 1 bit. So now what we're going to do is that we're going to have 4 of them. As you can see right here, this is a very rough drawing of the first part of Lab 2, but it's basically what it is. There's a clock signal that comes from the DE10 light and goes into the flip-flops. The output of the flip-flops goes into this 7-segment decoder, which will be on your display, and then the output of this goes into logic, and then the output of this logic will go back to the D flip-flops. Now, the reason that this kind of feedback loop exists is that we're making a counter. So this logic will output the next number in the sequence depending on what the current number that we're on is now. So when you start up the program, all the D flip-flops, their outputs are going to be 0. So Q3 is going to equal 0, Q2 is going to equal 0, so on and so on. So then when we start at 0, the next number is going to be 5. So this logic right here is going to output the number 5. Then when it's 5, the next number is 2, so it's going to output 2. Then when it's 2, it's going to output 1, and so on and so on. So this logic will basically output the next number in the sequence. So the point is that whenever the clock goes high, the flip-flops will be updated with the next number in the sequence, which will then go to the 7-segment decoder, and then the logic will output the number after that. So the general thing is that when there's a rising edge, there should say rising there, the new number will go into the flip-flops, the output of the flip-flops will go to the 7-segment display, and then the logic will have the next number. So let's say that the flip-flops have the number 2. The logic will output 1 because that's the number after 2, but the flip-flops aren't updated until a rising edge. So the flip-flops hold the number 2, and the 7-segment display shows the number 2. Now a rising edge happens. We have one of these guys. What's going to happen is that the flip-flops will be updated to have 1 because that's what the logic was outputting. That's where the input of the flip-flops is coming from. So the 7-segment display will now show 1 because it just takes the output straight from the flip-flops. And the logic will now output 4 because 4 is the next number in the sequence after 1. So then this will repeat for every single number. Once the flip-flops have 1 and the logic outputs 4, whenever there's another rising edge, the D flip-flops will now hold 4. Then the number after 4, I'm not sure what the number after 4 is, but whatever number it is, the flip-flops will contain that one, and then it'll go so on and so on. And because the last number in this sequence is 7, and then it goes back to 0, it basically jumps back to the start because the logic will then once again output 5. So basically, we have a bunch of flip-flops that will hold the current number that we're on. This number will go to the 7-segment display so we can see it, and this number will get sent to logic, so the logic will tell us the next number. Then whenever there's a rising edge, the flip-flops will get updated with the new number, and then the 7-segment display will show the new number, and the logic will have the number after that. If you have any questions, do not hesitate to reach out to the PI that leads your lab section, any PI that's holding an office hour, or just post it in the Slack help channel, and I hope you guys have a good night.